Okay guys, in our last video we looked at the matrix operations of addition and subtraction. In this video we're going to be focusing on the matrix operation of scalar multiplication. And so what I'd like to do before we do anything else is really just define what we mean by a scalar, okay? And so we say mathematically a scalar is just a real number, okay, by which we multiply, and in this case by which we multiply a matrix. And I would just like to comment that a scalar really is a real number we multiply by in many instances in math. And its purpose really is just to scale things up or scale things down. So for instance here, if I had, say, a triangle, a 3, 4, 5, and I took everything on the outside of this times 2, we would have this new triangle that would look similar to the original. This would be an 8, this would be a 6, and this would be a 10. But we would say that the number that I multiplied everything by here, we refer to this as a scalar. And so we say scalars scale things. And that's what we want to know about a scalar. They don't necessarily change relationships. What they do is they just change the scale or the size of things. And so when we talk about scalar multiplication with matrices, we say it's really just the process of multiplying every single entry in the matrix by some real number that we refer to as a scalar that's going to scale things up or scale them down. So looking at this, it says when we scalar multiply with matrices, we treat it much like the process of distribution when we talk about working with real number multiplication. So considering this expression right here, let's say 2 times a. In our last example here, we had a matrix A, which was a 2 by 2, and it was this -1, 3, 3, and 7. So I'm using the same 2 by 2 matrix A here, but if I were to take 2 times A, then I would re-represent this or rewrite this as 2 times out in front the matrix A here. So we write our scalars right out in front of our matrices here, kind of like you would with a real number in front of parentheses. But you'll notice here that what I end up with is this new matrix that is still, okay, a 2 by 2. So we haven't changed the order, but what we have done is really just taken everything, every entry in the matrix times 2. And so we get 2 times -1, which is 2 times -1, which is -2. And likewise, we say 2 times 3. Well, 2 times 3 is 6. 2 times 3 here is 6, and then 2 times 7 here, well, that would give us 14. So in our last video, we looked at an example where we added a plus a. But, algebraically, we say this is the same thing as 2 times a, and this kind of leads us to this result of, well, scalar multiplication really just means then what we're doing is taking all of the entries in the matrix times a scalar that we put out in front. So recalling from our last video here, and I'm gonna pull these back out. I'll click back over here. Our matrix B, okay, was also a 2 by 2. It's -2, -3, -10, and 5. So -2, -3, -10, and 5. And then we have this matrix A here. What I want to do is I want to just evaluate sort of these matrix expressions here to simplify and see what we get. So when I say 3B, well, let's go ahead and rewrite this. We say 3B really is 3 out in front of our matrix B, which our matrix B is this 2-row, 2-column matrix with the -2, -3, -5, and a 10. So we'll just get a new 2 by 2 matrix here, and we don't have to show our work. We basically are going to triple all of the values on the inside of this. So 3 times -2 is -6, 3 times -3 is -9, 3 times -5 is a -15, and 3 times is 10 here is a 30. So easy as that. Scalar multiplication is one of the easiest operations to carry out next to addition and then followed by subtraction. So when we look at, say, this last expression here, 2a times 3b, there is one thing that I want to mention in this example, and I'm going to try to get this out of the way here. Okay, that's better. 2 times a, so we have 1, -1, 3, 3, 7, okay? And this is plus now 3 times b. So 3 times b, okay, we just did this in the last example, but I'm going to rewrite out the original expression. This b matrix is -2, -3, -5, and 10. And what I want to write here is a little note. We say, basically, when you evaluate matrix expressions, you still need to use the same order of operations we would with real numbers. So when evaluating matrix expressions, use the same order of operations as with real numbers. And so what I mean to say is this. What we're about to do here is scalar multiply and add some matrices. So it begs the question, like, well, which one should you do first? Should I scalar multiply both of these by the scalars, or should I try to add the matrices and then do something else with the scalars? Well, what I want to make sure we mention here is this. Order of operations still applies. And so in terms of scalar multiplication, it certainly does fit right here in your order of operations when, you know, we talk about multiplication and division. Neat thing with matrices is division is not defined. But you know, it's neither here nor there. What I'm going to tell you is multiplication definitely comes before addition. And so when we do these, you do need to distribute your scalars first, okay, to all the entries in the matrices, and then we'll add them together. So let's go ahead and do that here. Suppose we would get something that looks like this. So still a 2 by 2. We would have doubled all the entries in here. So we get -2, 6, 6, and 14. And then we would have tripled all the entries here, kind of like we did in the last example there. We say -6, -9. This would be a -15, and this would be a +30. And then what we'll do is we'll just go ahead and do addition. And so what do we know about addition? Well, we know we can only do it if they have the same orders, and they do. So we're going to get a new 2 by 2 matrix where we're just going to add component-wise or entry-wise. So first row, first column plus first row, first column. -2 plus -6 is -8. We'll go first row, second column. 6 plus -9 is -3. Okay, second row, first column. So 6 plus -15, that's a -9. And then 14 plus 30 here, we would get a 44. And so this entire expression would simplify down into this 2 by 2 matrix right here. So order of operations applies. In scalar multiplication, just think about it as real number distribution. Okay, cheers.